looping animations, pulsing effects, and procedural stripes. These are just 3 of the many materials we can create using sine and cosine. In this video, I'll break down what they are both in a mathematical sense and in Unreal Engine materials. Then I'll show you how we can use them by creating practical visual examples. So let's do it. What are sine and cosine? Sine and cosine are trigonometric functions. They can relate the angles of a triangle to the length of its sides. Here are how they can be calculated on a triangle. These 3 are the core trigonometry functions: sine, cosine, and tangent. We also have the tangent node in materials, but I'll cover it in another video. Let's check it on a unit circle which has a radius of 1. Imagine any point on the circle. The distance from the point to the center of the circle is 1. Now imagine a right angle triangle here. That means one of the angles is 90 degrees. According to the previous formulas, the sine of this angle is equal to the vertical side of the triangle, and the cosine of the angle is equal to the horizontal side. So sine gives the y coordinate of the point on a unit circle, and cosine gives the x coordinate of the point. And it's true for any point on the circle. But that's enough about what sine and cosine mean in angles. If you want to learn more about that, I recommend the Khan Academy tutorials on this subject. Trigonometric functions are also important in modeling periodic phenomena. This is what we can use in materials. They both output values that smoothly oscillate between -1 and 1. This is the sine output waveform, and this is the cosine output waveform. They're exactly the same, except that sine starts at 0 and cosine starts at 1. We'll get more into the differences in the considerations part of the video. So now let's go to the Unreal Engine materials. Sine and cosine nodes. Right click in the material graph and search for sine. Here it is under math. We can also see the cosine node here. These are the nodes we'll focus on in this video. So let's add them. They both have one input, one output, and a period value in the details tab. I'm gonna go over it in a little bit. This section here adds a description to the nodes. All the nodes have it. So what can we do with these nodes? We know that whatever we feed into them, the output will be between -1 and 1. This can be extremely useful in creating animated or procedural effects. If we feed a constant into them, the result will be a constant value. But if we plug something that's always changing into them, like time, the output will oscillate between -1 and 1. Let's add the time node and connect it both into the base color input and the emissive color input. By default, time is always increasing, so using it like this is kinda useless. But if we first connect it into the sine node and then connect it to the base color and emissive color inputs, we now have an animated effect that loops. We can divide the time to control the speed of the animation, or multiply the result of the sine to change the range. In this formula, x is like time. Here's what happens if we divide it by 2. It affects the frequency of the wave. That's how it becomes slower. Now if we multiply the sine by 2, we can see that it affects the range. The waveform is in the -2 and 2 range now. The same is true for cosine. We're gonna use this in the examples part of the video to manipulate the results we get. The period value controls the input mapping. By default it is set to 1, so it means that a full cycle starts at 0 and ends at 1. If we want these nodes to work like they work in other programs and math functions, we should set the period to 2 pi, which is 6.283185. In materials, 360 degrees equals 2 pi radians, but still having access to this value can give us control over some effects. For example, let's set it to 1 and use it with a linear gradient. If we connect the gradient to the base color input, we can see that it starts from 0 on the left and increases to 1 on the right. Now if we run it through a sine node first and then connect it to the base color input, this is the result. It starts at 0, goes up to 1 here, then decreases down to -1 and finally comes up to 0, just like the waveform. Now this is because the period of the sine and the length of the gradient are the same. The gradient is from 0 to 1 and the period is set to 1. Let's also check it with the cosine node. It starts from 1, goes down to -1 in the middle and then comes up to 1 at the end. If we change either the length of the gradient or the period of these nodes, we can control how the final result looks. For example, if we set the period to 2, it starts from 1 and goes down to -1. It's like it's cut in half. And if we set the period to 0.5, it starts from 1, goes down to -1, comes up to 1, then again goes down to -1 and comes up to 1. So now if we set the period to a low value like 0.1, we can get black and white stripes. Let's set the period to 1. We can also change the range of the linear gradient and get the same effect. For example, if I add a multiply node after the gradient and then connect it to the cosine. Now if I multiply it by 2, we get 2 stripes, and if I multiply it by 10, we get 10 stripes. Now we can use a multiply node or a power node after the cosine node to change the way these edges look. We can also test them with the radial gradients to see how it looks. Next, we'll go over some considerations when using these nodes. But before that, if you're finding this helpful, like the video and subscribe. You can get early access to videos and download the tutorial project files, including the project file of this video, by becoming a supporter on Patreon. And if you want to stay connected and get help when you need it, check out our communities on Telegram and Discord. All the links are in the description. Considerations. We can use the plot function to visualize these nodes. This is the sine node. Because the period is set to 1, a full cycle is 1 unit. Now if I change this period to 2, as you can see, a full cycle takes 2 units. Also, let's see the cosine node. Base color can only output values in the 0 to 1 range. Emissive color can output values higher than 1 to, but the point is that we don't really need negative values in our materials. If we remap the sine and cosine outputs from -1 and 1 to 0 and 1, the output will be more reliable. And we can do that easily by adding 1 to it and dividing it by 2. Notice how before remapping, the darker part of the wave dominates. That's because the wave spends more time below 0, which gets clamped to 0 in base color. The constant bias scale node can be used instead of the add and the multiply nodes. It has 2 parameters in the details tab. Bias is the same as add and the scale is the same as multiply. They're also the same in terms of performance, just another way to do it. We could also use the remap value range function to change the range of the values to 0 and 1. When we remap the values to 0 and 1, sine starts at the middle, which is 0.5, and goes up, but cosine starts from the top, which is 1, and goes down. We can multiply the cosine by -1. This results in it starting from 0 and going up, so the choice between these depends on where you want the wave to start. Other than that, they function the same. We have these 2 functions in Unreal Engine materials to convert degrees to radians, or radians to degrees, but it's good to know that 2 pi radians equals 360 degrees. Earlier I mentioned that sine starts at 0 but cosine starts at 1. If we want to be exact, the output of the cosine expression is offset 1/4 the period, as it can be seen here. We can think of cosine as a sine wave that has a shifted phase. When the period is set to 2 pi, cosine is shifted half of pi radians, which is 90 degrees. All effects using sine and cosine happen on the GPU. No CPU logic is involved. Adding multiple sine and cosine waves with different periods can create interference patterns. This can be useful in creating non-repetitive motions, but avoid simple harmonic period values like 1, 2, or 3. They can align and create repetitive patterns. Instead, use non-integer or irrational ratios. Here I've used 0.9, 1.22, 2.34 and 3.13. But if I set them to 1, 2, 3 and 4, we can clearly see the repetition. Linear sine is an in-engine function that we can also use. Co in cosine stands for the word complementary. In trigonometry, complementary angles add up to 90 degrees. That's why cosine of an angle is equal to the sine of 90 minus that angle. Examples. If you don't know any of the notes I use in these examples, check out the material notes playlist on my channel. I'll put the link in the description below. Let's start with something basic. Add a time note and a sine note. Connect them like this, and let's bring the sine output in a 0 to 1 range. So for that, hold A and click to add an add node. Hold M and click to add a multiply node. Connect them, and let's set the B value of the multiply to 0.5. Connect it to the emissive color input. Hold 1 and click to add a constant. Set it to 1 so it becomes white, and connect it to the base color. Actually, let's connect this to the base color too. Save it and assign it to your mesh. Now we have a pulsing effect. Let's add some more control to the material. Hold V and click to add a vector parameter, and let's name it color. Set the default value to white, and we should multiply it by this one. So hold M and click to add a multiply node, connect them like this. Let's add another parameter to control its intensity, so I'll name it glow intensity. Set the default value to 1, hold M and click to add a multiply node, connect them like this, and connect it to the emissive color input. Now to control the speed of the animation, we should add a multiply node right after the time node. So let's move it here, hold M and click to add a multiply node, connect it, hold S and click to add a scalar parameter. Let's name it speed. Set the default value to 1, connect it, and connect the multiply node to the sine node. Save the material. Let's now connect the constant to the base color. Save the material again, and let's move it here. Now I can set the glow intensity to something high like 100, and we can see the effect. Let's also change the color to something like yellow, and we can control the speed with this parameter. Let's set it to 0.5, and we can see the effect. Duplicate the material and open it. In this one I want to use the seal node, so let's add it Here it is. The ceil node rounds up floats to the next integer value. For example, 1.5 becomes 2 or minus 0.5 becomes 0. Using it after the sine node gives us this type of waveform. So let's use it here instead of adding and multiplying the sine value. Let's delete these two. Connect them like this and move it down. Save it and let's assign it to display. Now as you can see, we're getting this result which turns the light on and off, and if we move it close to the other one we can see the difference. This one just turns on and off, but this one slowly increases and slowly decreases. We're gonna use the time and the sine node in all of the materials, so I'm gonna keep this logic in the materials by default so we don't have to spend time adding them. Hold 3 and click to add 2 vector 3s. Let's set this one to red and this one to blue. Hold L and click to add a lerp node. Connect the red to the A input and the blue to the B input, and I'm gonna use this logic as the alpha. So let's connect it. Connect the lerp to the base color input, and now if I turn on real time, we are looping between these two colors. Now let's do it with 3 colors. So let's move these up. Duplicate this one by pressing Ctrl D and let's set it to green. Right click, search for lerp 3 and add the lerp 3 color function. Connect them like this, and again I'm gonna use this as the alpha. Connect it to the base color, and now it loops between these 3 colors. Next I want to introduce some distortion into it. For that we need to add noise to the time. So let's move these two here. Hold T and click to add a texture sample. From here search for Perlin. Here it is, the Perlin noise from the starter content. Hold A and click to add an add node. Connect them like this. I'm gonna use the G channel. And let's use this for the sine. And here's the result. Let's set the speed to 0.5. Now we can even add animation to the noise texture. So let's hold P and click to add the panner node, connect it to the UV's input of the texture, and let's set the speed to 0.03 in both X and Y axis. And here's the result. Now the noise texture also has animation and we get this cool result. Let's also multiply it by a scalar parameter and let's name it glow intensity, and connect it to the emissive color. Now we can increase it and see the result. Save the material and let's assign it to our plane. Let's set the intensity to 20 or 10. Yep. We can use the same logic to animate a mesh's movement. Right click and search for append and add the append menu node. Connect this one to the B input because I want it only to move in the Z axis. Hold 1 and click to add a constant. Let's connect it to the R and the G inputs so that it doesn't move in the X and Y axis. And let's connect it to the world position offset input of the main material node. Now the sphere starts moving a little bit, but it's so little because it's moving only 1 unit, which is 1 centimeter in Unreal Engine. To control that, we should multiply this by a scalar parameter. So let's hold S and click to add it, and let's name it max offset. Set it, the default value of 0 is fine, and connect it to the B input. Save the material and let's assign it to the sphere. Now, if I increase the max offset value to something like 100, now the sphere goes up 100 units and comes down. And if I decrease the speed, we can see that it slows down. Using the absolute node after sine gives us this type of waveform. So in the previous material, let's use it instead of adding and multiplying the sine output. So right click, search for ABS and add the absolute node. Connect the sine and connect it to this multiply node here. Save it and let's assign it to this sphere. And as you can see, it's like a bouncing ball. This is the previous example and this one is using the absolute node. Let's also use the seal node to see how it looks. Connect it like this. Save the material, and as you can see, the sphere spawns in the min and the max height. Now let's animate a circular motion. Cosine derives the x-axis movement and sine derives the y-axis movement. Together they can form circular motion using this formula. X is equal to cosine of time and y is equal to sine of time. So let's duplicate the previous material and open it. Here let's delete the constant and let's also use the absolute node. Rename this one to max z offset and this one to z offset speed. Duplicate these two nodes and connect the time into it. This parameter will control the circular speed. So let's change the name to circular motion speed. Set it to something like 1. Set both of them to 1 actually. And add a cosine and a sine node. Connect them like this, and now this one should go into the R input and this one should go into the G input, so that the cosine controls the X and the sine controls the G, which is the Y. But to control their range, we should add a multiply after both of them. So select this one, press Ctrl D to duplicate it 2 times and connect it like this. Hold S and click to add a scalar parameter and let's name it circular motion radius. This one controls the radius. The default of 0 is fine. Connect it to the B input of both of them. Save the material and let's assign it to the sphere. First, let's set the max z offset to 0. And now let's control the circular motion. We can increase the radius to something higher like 100, and as you can see, it moves in a circular motion. Let's set it to 200, and the speed is too high. Let's set the speed to something lower like 0.1, 0.50. Now we can combine it with the z offset speed. So let's set the max z offset to something like 100. And now it's like a ball bouncing. Let's add a linear gradient and run it through a sine. Connect it to the base color, and let's set the period to something low like 0.1. So this is the result we get. If we connect it to the world position offset input and use it on a plane with enough vertices, it creates waveforms. So let's first bring it in the 0 to 1 range. Connect it to the base color. Add and append many nodes. Append many. Connect it to the B input and connect the RGB output to the world position offset input. Let's add a parameter to control the offset intensity. So hold S and click to add a parameter. Name it offset intensity. Hold them and click to add a multiply node. Connect them like this and connect it to here. Let's also set the period back to 1. Add a multiply node after the gradient to control the number of the stripes. Save the material and let's assign it to our mesh. Let's see the wireframe. As you can see, this is a high polyplane. Now we can tweak these parameters to change the result. For example, let's set the stripes to 10 and let's set the intensity to 2 or 5. Here's the result. Now we can animate the wave by adding time to the gradient. So let's move this here, add the time node, hold A and click to add an add node, hold S, click to add a scalar parameter, let's name it speed. Set the default value to 1, multiply these two together and add them together. Save the material and here's the result. Let's decrease the speed to something like 0.5. Now what if we use a radial gradient? So let's close this one, duplicate the material and also the plane. Assign this to this plane And here, let's delete the linear gradient and search for radial gradient exponential. The default inputs are okay. Let's connect it. And if you want to know what it looks like, this is the preview mode. This is the result of the radial gradient exponential function. Save the material. And now here's the result. We can control the number of the stripes here, the speed here, let's set it to 2 or 5 or 0.1. 0.5 is fine. If you like these kinds of videos, head over to my Patreon. Donating gives you access to my videos before anyone else. You'll also have access to the project files. So that's it. Click here for more Unreal stuff, and thank you so much for watching. Massive shout out to my patrons for making this possible. Like this video, subscribe, and join our communities. If you have any questions, leave them in the comment section below. So, see you in the next one.